question is asking, do the following make straight lines, yes or no? And it gives you a hint that says, if it does make a straight line, a table of values is a nice way to check. So if we made a table of values for the dog sled one, distance is related to time. Which one is independent? Which one is dependent? Because if we're making a table of values, we always put the independent one first. Time is independent, and distance depends on the time that you've been traveling. Okay? So dog sled team moves at an average of 10 kilometers per hour. So if the time was 1 hour, how far would you travel? 10 kilometers. If you went for 2 hours, 20. 3 hours, 30. Is this linear?
Yes.
Yes, because you're going up by the same amount here. You're going up by the same amount here. And anytime your y values go up by the same amount and your x values go up by the same amount at the same time, then you are going to get a linear function. The second one, again, we have to decide, we make our table of values, which is dependent, which is independent. The area of a square is related to the side length. So the area depends on the side length. So we would put side length here, area here. If the square has a side length of 1, what's its area? 1. If it has a side length of 2, what's its area? 4. If it has a side length of 3, what's its area? 9. Do you see that you have enough to check now? Up 1, up 1. So our x values, our side length are going up by the same amount. Are these going up by the same amount? No. No. So as a result, we would say this is not a straight line. Example number 5. A water tank on a farm near Swift Current holds 6,000 liters. I guess it doesn't really matter where it is, but there's a water tank that holds 6,000 liters. Graph A represents the tank being filled at a constant rate. And graph B shows it being emptied at a constant rate. Which is faster, filling it up or emptying it? Emptying is going faster. Independent and dependent. Which one would be independent? Which one would be dependent?
Time. Dependent. Time.
Time. Dependent.
Volume.
Perfect. Determine the rate of change. So rate of change is your change in y values. Oh, sorry, that was a fancy symbol for change. Okay, tone it down a little bit. Rate of change is your change in y values divided by your change in x values. And we call that, another word for that is the slope. So in the first one, in graph A, if you choose any 2 points, and in a straight line, it will not matter which 2 points you choose. So let's say I choose this one and this one. I would be going over this many and up this many. If we label the vertical part, can you see that that's your change in your y values? The horizontal part will be the change in your x values. How much am I changing in my x values? I'm going from 20 to 60. I'm changing 40. How much am I changing in my y values? I'm going from 1,000 to 3,000. I'm going up 2,000. And we consider going to the right positive and going up positive. Does it make sense that going down would be negative and then going to the left would be negative? So it depends how you draw the green lines. Either you're going to draw things positive or negative. Okay? So in graph A, if my y values are 2,000 and my x values are 40, can you see that this simplifies? We could simplify it to 50, and, or is it 500? No, it's 50. Changes to 50, and what is the y values? Our volume, okay? And what is the volume measured in this one? Liters. The x values are time in minutes. So right now, you are filling 50 liters per minute. Is that a lot?
Yeah.
That's good. That'd be like an ice cream pail, big ice cream pail is 4 liters. Be like adding 12 and a half of those in a minute. That's pretty fast.
A lot faster than your tap.
Yes, that is probably faster than your tap. Ooh, that'd be a good question to Google. How fast does water come out of your tap in liters per minute? There's probably somewhere on the internet that tells you. Someone's going to Google it. Now in graph B, so this is how fast, if we want to describe what it, the rate of change is describing how fast it's being filled. For graph B, we could take 2 points. So let's say I choose this point and this point, and I go down and over. Can you see that I've gone down 2,000? So I'll put a negative there. But after I've gone, I'm still going to the right, so I'm going positive 20.
Anywhere from 7.5 to 11.35
liters per minute. So we just found out generally a tap is flowing out at 7 liters per minute, 7 to 8 liters per minute. This is going 7 to 11. Oh, Slurpees. We find out how fast a Slurpee comes out. So this is coming out a lot faster than your tap.
How would you know which points to put it at? Like, when you put it?
You could pick anywhere. And that's the beauty about the rate of change on a straight line. It will be the same no matter which you pick. And I'm going to show you that after we finish this one. So for graph B, the y goes down 2,000, the x goes to the right 20. If we simplify this, we get negative 100 liters per minute. And this represents how fast it is being emptied. So Violet asked a great question. Would it matter if I change the points? Because I could get different triangles. So I'm going to do graph A again, and I'm going to say, but I use this purple point and this purple point. Would I get a different answer?
No.
Well, I go over this way, up this way. Now, going up is only up 1,000, so that number is different. And going to the right is only going over 20. So then my rate of change would be change in my y values plus 1,000.
1,000 over 20.
And then when you reduce it, it comes out to 50 as well. So really what's happening is, it's kind of like, you know how 3 over 2 as a fraction is the same as 6 over 4? Same sort of thing is happening with fractions here. We're getting the same fraction, but the numbers are different. But when you reduce it, you will always get the same one. So we always do want to get that into lowest form, so that we have a way of comparing. Interpreting the graphs of linear functions. Some very important points on graphs are the x-intercept and y-intercept. And these words in English are very easy to remember the definition, because the y-intercept is where the graph like crosses or intersects or intercepts the y-axis. And the x-intercept is where it crosses the x-axis. So this is your y-axis, this is your x-axis, and it's pretty easy to see those definitions. The interesting thing is that it doesn't matter where your y-intercept will be. Can you see that the x-coordinate has to be 0, something? No matter where it would be. And for your x-intercept, what would have to be 0? Yeah, now you just do your algebra. Well, maybe think of this as dividing by 9. How would you get rid of that? For your x-intercept, does it make sense that no matter where it is, that your y-coordinate has to be 0? And that's actually going to be a strategy. If you have the equation and you want to find an x-intercept, you can just plug in 0 where the y is. And then you'd have an equation you could solve for x. And if you wanted to find the y-intercept, you could just plug in 0 for x. Oh, and this will come up another 7,000 times before you finish grade 12. All of this stuff. I keep going and we learn something new. I'm like, ooh, this is really important for the rest of you. Ooh, this is really, ooh, all of this stuff. Learn it well in grade 10. When we study for that final exam, study, 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 because you're going to use it over and over and over again. And I'm actually, of all my classes, I'm most excited for students in grade 10. Because I think with the pandemic, it hurts students who are in grade 11 right now. It's hurt students who are in grade 12. You guys had the pandemic in grades 8 and 9, and you are going, if you work hard in grade 10, you're going to be just fine. I think pandemic-wise, I think the best for students, the best years to be in the pandemic would probably have been grade 6 and 7, or grade 7 and 8. Because like, if you missed middle school, you didn't miss much. Perfect, thank you. Okay. This graph shows how the height of a burning candle changes with time. Does it make sense that if you burn a candle, right, it goes down till you get to here, and if you leave it, your house starts on fire, and that's not good. What is the x-intercept? The x-intercept, if we labeled it as a point, the x value would be 45, the y value would be 0. What does it represent? But what in particular in this example? So you can't, when it says what does this represent, we really want to describe it in context.
When the time it takes for the candle to be completely burnt out.
Whoa, 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 whoa. Okay, go ahead. She was in mid-sentence. Yeah, go ahead, Haley.
When the time, it's, yeah.
Well,
The candle's all gone by 45 minutes. There.
candle is all gone. In particular, time it takes for the candle
Burn up.
to burn out. Good words. It takes 45 minutes for this candle to burn up. What is the y-intercept? Well, now 10, comma 0, oops, 0, comma 10. Right now the x is 0, the y is 10.
For like the x, like how does it?
X-intercept?
Just for like intercepts in general, and it says x and y, it will always be 0. Like
Nope.
will it always be 0?
One of them, for x-intercept, the y will always be 0.
And then for
'Cause-
the y, the x will always be 0. Like
Yes.
always.
Always.
Okay.
Because any point that you put on here, here, anywhere, or there. Anywhere you put that point, does it make sense that the y coordinate has to be 0? Okay, so what does the y-intercept represent?
The height of the candle from the beginning.
Yes.
When it first got lit. Or at the beginning.
The height of the candle
Before burn?
at the beginning. Sometimes you'll see this word. Does that make sense? To the initial height, the starting point. Oh, you guys are really good at domain and range now. What do you, choose and pick set notation or interval? What would you want to do? Set notation. Okay, so we're going to do set notation for the domain, set notation for the range. I give you 10-second head start.
Which one is that again? Is that the
Less than or equal sign.
oh okay.
All right, how did you do for domain? Ooh, it's a T. Sneaky. 0, less than or equal to T, less than or equal to 45.
So if we put an X, it would be wrong.
Well, in this case, it has a T listed and an H listed on this graph. I might, if you had an X, it wouldn't be wrong, it might be a half mark. And maybe I'm generous that day, I'd be like, oh, you know what you're talking about. Okay, but we should be careful in that. Same thing, range here, 0, less than or equal to H, less than or equal to 10. Graph represents a relation between the cost of an electrician's house call and the time he worked. Okay, write down the y-intercept, write down the x-intercept. Thank you.
No, it doesn't actually.
Oh, yeah. Is there an x-intercept? What does it represent? So y-intercept here, did you get 0, comma 60? What would we call that?
Initial cost.
The initial cost, like, that's how much you get charged, whether they work or not.
Flat rate.
Yeah, it's like their flat rate. Trying to think of some of the words that sometimes we have a service call. Sometimes they'll call that the service call rate. We come there, you already owe us $100. If we come there and you say, no, you know what, we figured it out, great, you still owe me $100 for driving. Charged.
Initially.
Initially, I'm just going to sure you can have that word in there initially. So you have some choice in your words as long as it makes sense to you in English what you're saying. Right? The amount charged for coming out, the initial costs. Okay? Is there an x-intercept?
No.
No. Why?
The cost is
The cost is
never 0.
never 0. It should be. Right? You get charged $60 no matter what. So cost is never 0. Are we good? Aiden, you ready?
Yeah.
Awesome. So one of the ways to sketch a line really quickly is if you use the x-intercept and the y-intercept. And they're really quick to find from an equation. You need to go back. And they're really easy to find because if you want to find the y-intercept, what point do you know already? One of them is 0. Is it the x-coordinate that will be 0 or the y-coordinate that will be 0? The x will be 0. So then I can go to the equation and say, well, I know that the x is 0. I don't know what the y is, but I know it's supposed to equal 4. So negative y then would equal 4, and multiply both sides by a negative. Y would equal negative 4. 1, 2, 3, 4. We can draw that point, label 0, negative 4. To find our x-intercept. So we could plug in 0 for x because we know that the x has to be 0. Yeah. And then we just have to do our algebra to find out what would make it work. Right? If I plug in 0 for x, 2 times 0, that's 0. I'm just left with minus y has to equal 4. Y would have to be minus 4, so minus a negative 4 makes 4. For an x-intercept, what do we know? We know the y-coordinate has to be 0. So if we put that into the equation, we don't know x. We know that we'd subtract 0 and it's supposed to equal 4. And now you can probably figure out what x has to be. If 2x is equal to 4, what's x? 2. So then you have 2 comma 0 as your x-intercept.
How did you get the minus 0?
Because we knew, here's the original equation,
Oh,
and now we know that the y has to be 0. Basically, what are we doing? We are making a table of values once where the x is 0 and once where the y is 0. And if the x is 0, we figured out the y had to be minus 4. If the y was 0, we figured out the x had to be 2. And if you have an equation that has one x, not x squared, not x cubed, not x to the minus 1, just an x to the 1 and a y to the 1, it will always make a straight line. So if we have an x to the 1 and a y to the 1, doesn't matter what numbers are in front, it'll always make a straight line. And if it always makes a straight line, if you find 2 points, if you find the x-intercept and the y-intercept, do you see that the only straight line that goes through those points looks like this? Could you find the rate of change? Could you find the slope of this one? Well, sure, there's 2 points. What's happening? We're going over 2, up 4. So your slope would be change in your y divided by change in your x. Your slope in this one would be equal to 2. Okay, try the next 2 on your own. find x-intercept and y-intercept. One of them is in function notation. 2 minutes head start. Getting pretty good with left hand, I like it.
Would you replace the,
We have our next quiz on Tuesday. And make us ready for a test on Friday next week.
would you replace the, oh, never mind, never mind. Alright. Did you divide it?
Yeah, 3x equals 12. How do I get the x by itself? Divide both sides by 3.
Oh, so for the 12 and the 2 for you to minus, you divide.
Divided both sides by negative 2. So there's our y-intercept. So we replace the x with a 0, or we replace the y with a 0. Do the algebra to solve then what x is. It's like figuring out your table of values. Then draw your straight line. How'd you do on the first one? And the last one. Then, this is what we're trying to find. We want to find the y-intercept. We would plug in 0 for x. Now, f of x is just another way, it's function notation, but it's another way of writing y. Okay, so this really is y equals 4 times 0, because we know that the x coordinate will be 0, minus 3. What would your y coordinate be? Minus 3. And then your x-intercept, you know that it's going to be something comma 0. You plug in 0 for f of x. Add 3 to both sides. Divide both sides by 4. Ooh, we get a fraction.
Can you go through that again?
Mm-hmm. You would estimate where it's going to be. Okay, so if you want to find a y-intercept, you know that the x has to be 0. You can go to the equation, and where the x is, plug in a 0. And now you're just doing your algebra. 4 times 0 is 0, minus 3, minus 3. Then for your x-intercept, you know that your y-coordinate has to be 0. So we plug in 0 for all of f of x, because that whole thing means y. And now we need to solve 0 equals 4x minus 3. You're using your equation skills. Add 3 to both sides. Opposite of multiplying is dividing. Divide both sides by 4, and you get x equals 3/4. When we go to graph this, we have a y-intercept at 0, -3. We have an x-intercept at 0.75, so we're going to have to estimate about 3/4 of the way. 0.75, comma 0. Drawing a straight line. So we can now take any equation and draw the graph really quickly. I mean, before you were making your table of values anyways, but now we're doing specific important points, the x-intercept and the y-intercept. If you wanted to find another point, for example, how hard would it be to plug in 1 for x? What would you get for y? If you plugged in a 1 for x and simplified it, you would get 1. That would be that point still on the line. Okay? If you plugged in 2 for x, you would get 8 minus 3, 5. So on our line, I should have, wow, it worked. Sometimes drawing it with just your hand, it gets a little crooked, a little bit off. I'm pretty happy that it wasn't too far off. We get 2, 5. So you can always find more points if you want with a table of values. But all you would need is 2 points, x-intercept and a y-intercept. Some students like to always find 3, because if it's supposed to make a straight line, and I got these in my 3 points, what does it tell you? Something went wrong somewhere, right? So some students like to find 3 points, because if they find 3 points and they're like, yes, they are in a straight line, chances are I didn't make mistakes. I mean, there's a very small possibility that you made 2 mistakes and they just happen to work out perfectly and be in a straight line, but it's pretty rare to do that. You think we should stop? We've got,
The rest of the ones are all the same.
look it,
I mean, you
we
can
should
go
just,
with them Monday.
you want to just work on your homework?
Yeah.
I think we should watch.
Oh, the homework, like the review.
You can work on the review
Oh, the review.
and do this on Monday, and then quiz on Tuesday, test on
What is
Friday.
Nothing better than a